Greetings, this is Unit 5, Module 4, Session 3. This is the Unit 5 Review Home Connection. It's a two-pager, name and number, please. Always good to get a review in before you do your end-of-unit assessment. So let's take a look. Looks like you are going to match the words below the box with the lines and shapes that you see here. So you're going to be trying to figure out which is perpendicular, which is parallel, where's a point, where's a right angle, and what's just a plain old angle. Okay? Some of these you might consider starting with first, like a point is usually like a dot that you might draw a line through, or a line might go leave a point. Okay? Right triangle is a triangle that has a right angle in one of the three interior angles. Parallel lines will never touch. Perpendicular lines do touch, but they touch in a specific way. They have to touch at 90 degrees. So you'll have a square angle there, or a right angle there. And we know that an angle occurs when you have two lines meet. Okay, so if you know, for instance, that this is a point, you would write in point, you'd cross it out, and then you'd try to figure out what the other pictures represent. Okay, circling the polygons in the box below. Let's see, I do have a nice definition of it here that we might as well look at. Ooh, it's kind of stuck though. Okay, here we go. So I've got my polygon vocab card here. Here's some good examples. And it does say a closed two-dimensional, that means flat, right, shape with three or more sides. Okay? So, closed, right? That means if you were on the outside of the shape, you couldn't walk into it, if that makes sense. Like, for instance, this one here appears to have not be closed. You could walk into that one, so I wouldn't choose that one. Oh, this is an angle. I wouldn't choose that one. Okay. And then at that point, we have figured out that these are just not closed shapes. Now, if you're going to circle the ones that are polygons, well, you probably need to see if you have three or more sides with these polygons, okay? I'm going to let you count the sides and determine which ones of these are polygons. If you can count three or more sides, you should circle it, okay? You're going to circle the polygons in this box that have exactly one line of symmetry. If I were to take, let's say, this shape out of my pattern blocks, and I trace it down here. So I've got just a square. I'm going to trace it just as a nice example. Okay, there's my square. I have a line of symmetry here. So if I go straight down the middle, I could fold it in half and it would be symmetrical. Oh, I could also draw a line of symmetry across the middle, and I could fold it that way. Oh, I could fold it along the diagonal. That would be a nice line of symmetry. Oh, and I could fold it the other corner and have a nice line of symmetry. So with this square here, I'd have 1, 2, 3, 4 lines of symmetry. You wouldn't want to circle that because that has too many. The instructions say that you're going to circle ones that have exactly one line of symmetry. Okay? And it wants you to draw the line too. Okay? So if I were to just do one with you, I'm going to look at this first shape. I'm kind of looking at this going corner to corner. I can't really fold that in half. That won't work. What about this corner? I'm thinking about this one here. And you could actually even fold your paper in half if you wanted to see if it works, or even cut them out. But visually, we should be able to do this. Let's see if I do one here. No, that doesn't work. And if I fold it this way, also doesn't work. So this doesn't even have a line of symmetry, so you wouldn't want to do that one. Okay. What about this triangle? I said I was going to do one, but I lied. I'm going to do two. Oh, I could fold this triangle like that. Oh, but then I could also fold it like that. Oh, and I could also fold it like that. So that one has 3 lines of symmetry, so we also can't use that one. Okay, so you're trying to find ones that have exactly 1 line of symmetry. You could fold it in half only one way, not more than one. Okay, I'm going to let you look at the last 3. A right angle measures 90 degrees. A square has all right angles. How interesting, I drew a square here. Circle the correct word to make each statement true. An acute angle measures more or less than 90 degrees. Oh, it's so cute. Do you remember that our acute angles maybe look something like that, whereas our obtuse angles look something like that? Okay, so if this is a square angle here, you know where we go. They're perpendicular. Okay. Acute angles are what? More or less? Less. Obtuse angles are what? Well, it has to be the other one, correct? Obtuse is bigger than 90. Acute is smaller than 90. So if you have your protractor, which I do right here, oh, that's a bad color to look at on the screen. Let's do this. Okay, so if I were measuring from 0 up to 90, right? Any angle measurement that's smaller than 90, if I were to draw a line to it, okay, has to be acute. Then at 90, it's a right angle, and the moment that my angle starts to get bigger, you're obtuse. All of these are obtuse. All of them, all of them, all of them, all of them, until it becomes a straight line. Okay? So keep that in your brainium as you go through those angles. Okay? So let's look at this page. Ooh, draw an example of the angle described in each box. An acute angle? Ooh. Now you could even measure it if you want. That would be fun. So if you wanted to draw an acute angle, you could just pick a number and then create it. So maybe start with a flat line. Okay, I'm going to put a point on it. Okay, arrow. Oops, you can't really see that, can you? Okay, so there's my 0. I'm going to call that my 0 line, because that's where 0 is going to be. Boop, boop. And then I'm going to make some sort of an acute angle. It has to be less than 90. So what if I decide right now that I'm going to do a 75 degrees? This is just for fun, right? So I put my crosshairs right on the dot. I line everything up so it looks perfect. Okay. Now I count from 0 up. I try to find 75, 70, and 80 is right there. So 75 is going to be somewhere in the middle. So I'm going to just take a really good guess at it. That looks like it's in the middle. Then I can connect my lines. And that is a 75 degree acute angle. Okay? As you go through the remainder of these boxes, a right angle is going to be exactly 90. If you have a protractor, great. If not, you can eyeball it, right? And then an angle that measures about 120. Well, if you need a little assistance, I can show you here that 120, if this is your 0, okay, and you will go all the way to 120, it's going to point up and out at a pretty high angle, okay? If you don't have a protractor, you can give it your best guess. That's totally fine. But we know that 120 degrees is going to be obtuse. So at least make sure it's obtuse, okay? Show your work using numbers, labels, sketches, or words. Of course we like to do it that way. An ant walked around a rectangular garden. One side of the garden was 16 feet long. The other side was 23 feet long. Well, I should probably draw this. Rectangular garden. So there's my rectangle. One side was 16, one was 23. This looks like my short side, so I'll make that a 16. The other is a 23. Okay. It says, how far did the ant walk? In other words, what was the perimeter of the garden? So if the ant walked all the way around, how far did it walk? Well, it walked 16, 23, 16, 23. right? Because we know the opposite sides have to be the same if we're talking about rectangles, okay? So, how far? You could add it all up. Or you could use our perimeter formula, which works pretty well too, where you could do 2 times 16, right? Because you're going to count 16 twice. And you're going to add that with our 2 23s. So you're going to count 23 2 times. And that's going to be your perimeter too. Don't let this version feel too strange to you, because you know that if you count 16 2 times, 16 and 16, okay, that's the same as adding both sides. And then if you count 23 2 times, you're going to have 23 plus 23, right? And then it is the exact same as this, it's just grouping it. Count the 16s, count the 23s, and then add them, okay? Make sure you label it in feet. But then it wants to know the area of the garden, and we know area is length times width. What's the length? 16. What's the width? 23. So you're going to take 16 times 23. Make sure as you're doing this, if you do standard algorithm, which I recommend, it's good practice, that you start with your 6. 6 times 3. Carry if you need to. 6 times 2. And then add whatever you carried. That'll be your first line. The second line has to start with a 0 before you take 1 times 3, and then 1 times 2, okay? And then when you're done, make sure you add down, okay? I don't want to do all of it for you because it's such good practice. There's no point in watching me unless you are super struggling with maybe the order, but that's the reason I kind of said 6 times 3, and then 6 times 2, that's the top row. Put in your 0, and then you move on to the 1. 1 times 3, 1 times 2. Okay, and that'll be your bottom row, and then add when you're done, okay? Obviously, I want you to go ask for help if that 2 by 2 is too difficult, okay? Clover is moving, or mowing, excuse me, and by the way, pause this video so that you can get this answer, okay? Clover is mowing her backyard. Her backyard is a rectangle, so we might as well, I like to, anytime I can visualize it, I always try to draw it. One side is 60, the other is 25. This is my short side, so I'm going to mark that as 25. That's 60. It took Clover 30 minutes to mow half of her backyard. So I'm just kind of penciling this in here, so it looks like she mowed about half of it. And that took her 30 minutes. What is the area of the space that Clover mowed? Oh, that's kind of a fun question, actually. Let's zoom in on this just for a pinch. She mowed half the yard. So the way that I highlighted it, because I could have done it 2 different ways, and I'm going to mark it, okay, just so you can see. I could have said she mowed this half, right? I could have split the yard that way. Well, the nice part about what I did is kind of like a happy accident, is that I split it on a number that's easy to divide, right? Because I still have my full 25 I'm working with, right? But I split this yard up on the 60 side. So what's half of 60? Well, half of 60 is 30. So this would be like 30 and 30, right? So the area that I did mow, I have a length of 25 and a width of 30. So my area should be 25 times 30. Okay? And you can use stats, you can do a couple things. Standard algorithm does work. It'll always work. But you could also do yourself a favor and get rid of this 0. Okay? And you could think to yourself, 25 times 3. Okay? We know that 25 and 25 is 50. Add another 25, and that's 75. And then you can put your 0 back on. Don't forget, if you get rid of a 0, to make the math easier, make sure you put it back on when you're done. Okay? Last but not least, we're talking about feet. And when you're talking about area, we're talking about like the number of teeny tiny squares that cover it, right? Because we're measuring in square feet. So don't forget, square feet is going to be your unit for that, okay? As usual, if you have questions, ask a math wizard, ask a teacher, ask a friend who loves math. We love to help, and we like to make sure that you know what you're doing. Later.